This is session 1 of lesson 28. In this lesson, we are going to be studying categories of two-dimensional figures. And so for this session, our learning target is I can understand the attributes belonging to a category of two-dimensional figures also belong to all subcategories of that category. To start, draw a shape with 4 sides, draw a shape with 2 pairs of parallel sides, and draw a shape with 4 right angles. Remember, parallel sides are sides that if they extended forever, they would never cross. And right angles are 90-degree angles. They are the angles that you can fit a square into. So pause your video and draw those shapes, and then press play again, and we'll check your work. So shapes with 4 sides, we have a lot of options there. It could look like this. It could look something like this. It could look something like this. And there's all sorts of different shapes that you can have drawn also, as long as it has 4 sides. A shape with 2 pairs of parallel sides. There's an option there. It could be a square like that, or a rectangle, or perhaps you drew a rhombus. And then a shape with 4 right angles. You could draw a square or a rectangle. So today we're asking, how can two-dimensional figures be grouped to show they are related? All right, let's go into that a little bit further. Number 1, polygons are described by their attributes, such as the number of sides or angles they have, and grouped into categories based on attributes they have in common. In the space below, draw an example of a rectangle and an example of a square. Then complete the table by writing 3 attributes shared by all rectangles and 3 attributes shared by all squares. So I am going to put up on the screen here a rectangle and a square. And looking at the rectangle first, there's 3 things that we can write down for attributes. Rectangles have 4 right angles. Opposite sides are equal length. And 2 pairs of parallel sides. So we can see we can fit a square into each of these corners there. That side and that side are equal length, and this side are equal length. And those 2 sides are parallel, and then those 2 sides are parallel. Okay, when we're looking at squares, it also has 4 right angles. All 4 sides are equal length. And it has 2 pairs of parallel sides. Number 2, letter A. What attribute do all squares have that not all rectangles have? So an attribute that squares have that rectangles do not have is they have 4 equal sides. Hey, letter B, circle the true statement below. Every rectangle is a square, or every square is a rectangle. I'm going to circle. Every square is a rectangle. Okay? Because not all rectangles have 4 equal sides, but all squares have opposite sides that are the same length. So squares fit the description of rectangles, but not all rectangles fit the description of squares. Let's look at number 3. A subcategory is a category that shares all the attributes of a larger category. Are rectangles a subcategory of squares, or are squares a subcategory of rectangles? So I'm going to actually show this diagram here, which I think is really helpful when looking at this. So quadrilateral, quad means 4, and lateral is a word that means side. So quadrilaterals are any 4-sided figure. And under quadrilaterals, there's 3 types of quadrilaterals. We have the kite, the parallelogram, and the trapezoid. And for this lesson, we're going to be following the parallelogram. So parallelograms are any quadrilateral that have 2 pairs of parallel sides. So these 2 sides are parallel and the top and bottom are parallel. Now, one kind of parallelogram, and we're using the word subcategory here. So one subcategory is a rectangle. Rectangles also have two pairs of parallel sides, but they also have four right angles. And then under rectangle, a subcategory of rectangle is square. Squares also have two pairs of parallel sides and four right angles, but the attribute that is added when we're looking at squares is that all the sides are equal. So the answer here, are rectangles a subcategory of squares, or are squares a subcategory of rectangles? We can see by looking at this diagram that squares are in fact a subcategory of rectangles. Number 4, this is the top of page 576. A Venn diagram uses ovals or other shapes to represent categories and to show how the categories are ordered in a hierarchy or ranking based on their attributes. How does the Venn diagram at the right show that squares are a subcategory of rectangles? So if we look at this Venn diagram over here, we can see that the circle where squares, the circle for squares, that sounds funny, is entirely inside of the rectangle category. We remember all squares are rectangles. They all fit the description for rectangles. However, not all rectangles can fit in the description for squares because some rectangles are squares that have four equal sides, but some rectangles have a longer side and then a shorter side. And so all squares are rectangles, but not all rectangles are squares. What is an attribute of a rectangle that is also an attribute of squares? So one option there is having four right angles. Squares and rectangles both have four right angles. They also have two pairs of parallel sides. Number 5, use what you know about triangles to write the labels isosceles triangles and equilateral triangles in the Venn diagram below. And we want to remember isosceles triangles have at least two equal sides. Equilateral triangles have three equal sides. So are all isosceles triangles equilateral, or are all equilateral triangles isosceles? So write down what you think, and then we'll check it. So isosceles triangles actually goes on this line, and equilateral triangles goes on this line. All equilateral triangles are isosceles because they all have at least two equal sides, but not all isosceles triangles are equilateral because some isosceles triangles only have two equal sides, and then the third side is a different length. Letter B. Use your Venn diagram to complete the statement below. Blank triangles are a subcategory of blank triangles. Equilateral triangles are a subcategory of isosceles triangles. Letter C. Describe two ways an equilateral triangle has the same attributes as an isosceles triangle. An equilateral triangle has three angles and at least two sides that are the same length, just like an isosceles triangle. Number 6, reflect. Based on your Venn diagram, is every equilateral triangle an isosceles triangle? Or is every isosceles triangle an equilateral triangle? Explain. This is where I'd like you to pause and write down your answer and then press play to check your work. So to answer this question, every equilateral triangle is an isosceles triangle. All equilateral triangles have two or more sides of equal length because they all have three sides of equal length. Not all isosceles triangles have three sides of equal length. Your assignment for this lesson is pages 577 and 578.